Good morning. Welcome to the 14th lecture, the 14th online lecture of this course. That's 14 online lectures, each 50 minutes long, approximately. You can run the math in your head. Okay. That's a lot of hours of lecture. Let me think of the hours here real quick. 14. So that's 11 hours and 40 minutes of lecture by the time we're done today. My dean asked me a question this morning, and so I went and gathered statistics for her on this course. The statistics that I calculated were gained from Moodle and from YouTube. And she agreed with me that the data was disturbing. The problem with the data is that many of you are not watching the lectures, and many of you are not paying attention to the course. Some of you appear to be accessing Moodle, but not the lectures. I've been giving out a fair amount of code in the lectures. Though that code does not exist in the PowerPoint slides. You cannot learn the material from just the PowerPoint slides. The lectures are essential. Last week's lectures had viewership consistently under 50%. I don't know how to get you to watch the lectures. I suppose I could start giving daily quizzes in Moodle on trivia from the lectures. What did I do at this point in the lecture, or what was this, some questions related to the material in the lecture. I shouldn't have to trick students. I shouldn't have to play games like that with students. You're here to learn. If you don't watch the lectures, you won't learn. If you don't watch the lectures, if you don't pay attention to the course, if you don't log into Moodle, which one of you has not logged onto Moodle in 21 days? Basically, since the first day of online courses, that was the last time you've logged into Moodle. Another student hasn't logged into Moodle in over 10 days. If you don't do the work, if you don't watch the lectures, if you toast test 3, if you toast the final, which is what will happen if you don't watch the lectures, if you don't do the programming assignments, you're going to fail. I have no way to keep you from failing. If I don't have enough points to work with, if you don't earn enough points to work with, then you will get the grade that you earn. If you earn a B, you will get a B. If you earn a C, you'll get a C. If you earn an F, you'll get an F. You can change to pass fail, and if you earn a B, then you get a pass, and if you earn a C, then you get a pass, and if you earn an F, then you get a fail. This crisis is designed to crank up anxiety. This crisis, well, it's not designed to do that, but it might as well be. It cranks up anxiety. It makes you withdraw. It makes you cut off from the rest of the world. Stay engaged. Please, please just stay engaged. Watch the lectures. Do the work. Some of you are really good at it. And some of you are, I don't know, I guess you think that somehow at the end you'll just be able to appeal to the dean or appeal to the university and get get a passing grade when you didn't earn it. That's not going to work. Like I said, I've already sent my dean the statistics and the names of students that I know are withdrawing, that are not withdrawing from the class, but have withdrawn from watching the lectures, from following the course on Moodle. She asked me specifically, and I'm sure she asked every faculty, how were the classes going? How were the students doing? And I had to dump statistics on her because I'm a data person. And I said, here's what the analytics tell me. And her response was, that's disturbing. That was the same as my response. I said to her, yes, it's disturbing. You know, it's 10 o'clock at night. It's past 10 o'clock at this point, 10:17 at night. I'm recording tomorrow's lecture right now. This has important information in it for the 8th programming assignment. We can make it to the end. We've got 3 more weeks of lecture. We've got a test and a final and a programming assignment. Well, one due tomorrow and then one that's going to be due in 2 weeks. Stay engaged. Please just stay engaged. With that, I'm going to move to the lecture. Second, this isn't the right lecture. Hold on a second. Okay. I just got confused just for a second. Easy to do. These are the slides. Just had to look through them real quick. So today, just like yesterday's lecture on insertion, I'm going to go through deletion or removal in painful detail. I do want to say something about the code that's in the slides. Both yesterday's slides for insertion and today's slides for deletion. The code that's in those slides does not have curly braces in it, okay? It was just easier the way I laid out the slides to drop curly braces. So you can't just type in the code, you have to know what the code, what the chunk or block of code is that you need to put into the curly braces for like the if statements and that kind of stuff. Okay. Also, this is all going to look sort of familiar because the cases for removal, the special cases and the normal case, are similar but not the same as the cases for insertion. And so we're going to have sort of a similar layout of the code, similar sort of structure to the code, but the code's obviously doing something different because it's removing, not inserting. So this should all seem a little bit familiar. The different cases require different code, and each case, just like insertion, can be identified using a sequence of ifs and elses. And the order of checking for the cases, just like the insertion, is important, okay? So what are those cases? For removal, the cases, there's a normal removal. That's you're removing some node in the middle of the list. And in fact, it's even the last node in the list. If you're removing the last node in the list, the normal removal works correctly. You've got a case for removing the only node in the list. So if you only have one node in the list and you remove it, that means that head has to end up being null because the list is now empty. So we need to make sure that's done correctly. There's another special case where we're removing the head. That is, the thing that we want to delete is the first thing in the list. Head points at the first thing in the list, so we have to move head to the second thing in the list in order to delete that front thing. There's not found. And so our typo, our remove pointer oh goodness, this is not quite right. I tell you what, I'm going to pause, fix up that slide, and I'll be right back. Okay, that took about 30 seconds, so I'm back. So back into our cases, I had just talked about removing the head, making sure that the head is updated correctly, and now not found. Not found has a couple of different ways to manifest itself. Either remove has walked off the end of the list, or it's been left pointing to a node that doesn't equal our data to be removed. And so we're going to have to return an error code, okay? In either one of those cases, we need to return the same error code. And it turns out that we can identify those cases at the same time with the same if statement. And so we'll see how that code gets structured a little bit later in the slides. The empty list is essentially a not found. So we're going to return the same code, the same error code, only this is going to be a case where there's no list to delete from or to remove from. So the order is important. Normal, and so normal removal, removing the only node or removing the head, and the not found cases all require comparing the data to be removed to data that is already stored in the list. So there has to be a list existing. If there's no list existing, then we're going to get a seg fault because we'll try to use a null pointer. And so the empty list, just like insertion, the empty list case goes first. So if it's an empty list, we're just going to return an error code, okay? The normal, the only node, the head, and the not founds can't be identified until after we search. And we're going to search for that removal point, the node that's going to get removed. And we're going to use the simple while. It's very much the same as the while loop we used in insertion. I've changed the test pointer name to the remove pointer, and previous is still previous, okay? So this is code in removal, but it's very, very similar to code that's in insertion. And so The else off of that empty list is going to have a search with a while loop in it. Once the loop finishes, we either have found a node whose data is equal to the remove data, or we'll have walked the remove pointer off the end of the list. So since remove will be null if it is walked off the end, we should handle the not found case immediately, because we don't want to try to use that removed pointer if it's null. And we're going to handle the other not found case at the same time. Okay, so if remove is null or remove arrow data is not equal to the data to be removed. So that's our two different not found cases. And in both of those, we're just going to return the error code. Now, provided the remove is not null, and we have either the normal case, the head case, or the only node case, it turns out that we can handle the head case and the only node case together if we're careful. And so that means that if remove is null or remove arrow data isn't equal to the data that we want to remove, again, man, I'm starting to realize I shouldn't have written these using the insertion code. Because things keep slipping in that were in the insertion code and not are in this. So if the remove is null or remove data is not equal to the data that we want to remove, we're going to return an error code. Else, if the previous is null, this is going to happen when we try to delete the head or we're deleting the only node. Otherwise, we've got the normal case. So here's the empty case. And from here on out, I'm like 99% sure that I've got all the code correct. It was the verbiage that kept tripping me up because I was editing the verbiage from yesterday's insertion slides. One of the things about having these online lectures is a lot of stuff that I would write on the board, I'm now trying to write into the lecture. And doing things like not drawing on the board, etc., turns out to be rather difficult. And so I'm having to rework all of the slides that I have for this course. So here we go, the empty case. Wow, that's it. If is empty, return -1. That's all you do. You've invoked the removal method in the linked list. You've passed in data that you wanted to remove. I've called that REM data. In this case, I said, hey, remove Dallas. Well, there's no list to remove it from. Head is equal to null. So the list is empty, and we're just going to return an error code. That's it. Well, then we have to do our search. So in the else of that if statement, we're going to have that while loop to do the search. So remove and prev are locally declared list node pointers. We set remove equal to head, we set prev equal to null. And then while remove does not equal null, so that is we haven't walked off the end of the list, and remove arrow data is less than rem data. So this while loop is going to continue to run until either we walk remove off the end of the list or remove data is equal to or greater than. So right here, if this relationship between rem data and remove data is equal to, the while loop will stop. And if remove arrow data is greater than rem data, it'll stop. Okay, so it's going to stop us on a not found case, either one of the two not found cases. And it's going to stop us if we have it equal to, which is going to be the removal cases. So we either found the thing we needed to remove using the while loop, or we didn't find it. So previous equals remove, remove equals remove arrow next, and we just walk those two down the list, okay? Well, as soon as this while loop is done, we're going to decode the not found cases. And this just cleans up some of the code for the other cases. So the not found case, if we've walked remove off the end of the list, that is remove is equal to null, or remove arrow data does not equal rem data, we return -1. Now this, if we go back up one slide to the while loop, or 2 slides, excuse me, there's this Boolean short circuiting right here. So the way the AND gets short circuited is if the first expression is false, you don't evaluate the second expression because you know the AND is already false. Turns out that C and C++ short circuit the OR as well. And so right here, this OR is going to be true if the first is true, the second is true, or both is true. Well, it turns out both are never going to be true, okay? It's never going to be the case that both are true. But if the first one is true, that is if remove is equal to null, then it doesn't evaluate the second one because it knows that the result of the whole thing is going to be true. If this is false, then it checks to see if data does not equal rem data. So because of this Boolean short circuiting again, we get to check both of these not found cases in one if statement, okay? And then we just return the -1. So we were called to remove Detroit. We got off to the end of the list and it was not what we wanted. Or we stopped short of that and it was not what we wanted. Either way works, okay? So remove head, or we're removing the only node in the list. So we know at this point, because this is the else of that not found case, we know that we found the thing we need to delete, okay? So if previous is equal to null, then the head and the remove pointer, so remove is pointing the same place as head. In this case, I've drawn them as both pointing to Dallas, which is the node that we want to remove. But I've also made the next link a bunch of question marks. And that's because, again, like the not found, we can handle a couple of different cases here. If Dallas's next is null, or if Dallas is pointing to more nodes in the list, that isn't going to matter if we write our code carefully. And so the code that I'm about to give you will handle either there's more list there or there's not. So this handles deleting the head or getting rid of the only node that's in the list. Either way it will work. And that all is because we do this. We set head equal to head arrow next. So head gets that value from Dallas's next. And that could be null. It could be a pointer to the second node in the list. And we really don't care. The code's going to work either way. So we've moved head. And then we just delete the node pointed to by remove. And so that gets returned to free space. So deleting that prevents a memory leak at this point, and we're done. We return 0 then. Okay, so we're returning 0 to say, hey, we finished. We're good. We no errors occurred. Okay. So you notice how our code doesn't depend on head arrow next being null or non-null. As it's written, it handles either of those two cases. And so in a linked list, the other thing to notice is that removal is assumed to not return a copy of the data that was removed. And this is a distinct difference from what was done with the stack and the queue. Stacks and queues impart order on data based upon its arrival. Linked lists store data for as long as it's to be used, and then when you remove it, it's assumed that you no longer need that data anymore, and so it just gets rid of it. If you needed the data, then you would conduct a search, which is another method that we'll cover, and we'll be covering the search or the find function for your linked list class, probably tomorrow's lecture. At least that's what I think. Okay, so with those two notes, we're going to continue on. And so now we have a normal case removal. And the normal case removal is pretty simple. We've stopped where remove is pointing at the data that we want to get rid of. So in this case, rem data, which was passed into our removal method, it says remove Detroit. And the while loop has walked remove and prev down. It stopped as soon as remove arrow data was no longer less than the data that we want to remove, the rem data. And so it isn't, it's equal to. So the while loop dropped out. It failed the check for not found. It failed the check for removing the head or removing the only node in the list. And so this is normal case now. So this is just a catch-all else at the end. So prev arrow next equals remove arrow next. So let's go back. I'm going to flip between these two slides a couple of times. So right now, Dallas is pointing at Detroit and Detroit is pointing at Syracuse. Prev is pointing at Dallas. Remove is pointing at Detroit. So right here, prev is pointing at Dallas. Remove is pointing at Detroit. Dallas is next, or prev next, is pointing at Detroit. Okay, and Detroit, or removes next, right here. So remove arrow next is pointing at Syracuse. Okay, so we're going to copy. Where's my mouse pointer? We're going to copy the address right here in Detroit's next into Dallas's next. And we're going to use prev and remove to do that. So we say prev arrow next equals remove arrow next. And that takes this and points it over here. Okay, bypassing Detroit. So the list right now is head points at Atlanta, which points at Dallas, which points at Syracuse, which points at nothing. Detroit is just sort of orphaned out here. It's like an appendix. And so now all we really need to do is delete Detroit. So deleting the remove pointer, the thing pointed to by remove, takes that and sends it back to free space. And we're done. We return 0. That is it. That is everything in a nutshell. That's everything that we need to do. And that's our deletion. So, you know, I'm looking at my timer, I'm looking at my watch, and I'm seeing about 15 minutes left in lecture. I started this lecture with a plea for you to stay engaged. I started this lecture with a affirmation that if you don't do the work, you're going to earn a failure. I feel for you guys. I really do. So I'm turning back on the video. The world has changed. You know, the world that I've lived in for almost 60 years has changed. The world that you've lived in for, 18 plus years has changed. It produces a lot of anxiety, a lot of fear of what the future is going to bring, fear of whether there even is going to be a future that isn't horrible. I believe that humanity will get past this. I believe that next year will be back to something sort of like what we had prior to this spring. I think we're going to get to the other side of this. I think you're going to get to the other side of this, but you got to stay engaged. Don't drift on me. Please, please don't drift on me. Keep watching the videos. Keep doing the work. And with that, I'm gonna let you out 14 minutes early on this video. There are days in class in every semester, every class in every semester where I'll let out class early, just because we're all kind of feeling burned out. I hit the wall last week. It wasn't pleasant. I was very angry, very frustrated. Several of my colleagues in math and computer science also hit the wall. And I can feel my students hitting the wall as well across all my classes. Try to push past it, try to get past it, try to stay engaged, try to get your work done. Okay? The world's been turned on its ear, and we have to rely upon each other in order to get through. If you need to talk, if you are struggling, if you feel like disengaging, drop me an email. If need be, we can sit and talk. In fact, something that was suggested by one of my colleagues I'm seriously considering doing, which is taking each and every one of you and scheduling just a 5-minute Zoom session to chat with you. So if you would like some time to chat one-on-one, Zoom or Google Hangouts, drop me an email, and I'm more than willing to just sit and talk about anything at all. So with that, take care. I'll see you tomorrow.